In 1977, a team of scientists made an extraordinary decision. They launched a spacecraft on a journey from which it would never return. It was humanity's way of saying to the universe, "We're here. This is who we are." More than 40 years later, that spacecraft is still flying. It is still sending signals back to Earth, like a letter arriving from the edge of the solar system. What's even more incredible is that many of the engineers who built it are no longer alive. But the machine they created is. Long after its creators are gone, it continues exploring the unknown on humanity's behalf. Its name is Voyager 2. Today, Voyager 2 is over 12 billion miles, 20 billion kilometers, from Earth, making it one of the most distant spacecraft ever built. But none of this happened by accident. Every maneuver, every planetary encounter, every tiny adjustment, was carefully calculated years before launch. The precision was so incredible that even the smallest error could have ended the mission. Today, I'm going to tell you how this spacecraft accomplished one of the greatest journeys in human history. The story begins in the 1960s. While analyzing planetary orbits, NASA scientists noticed something remarkable. Jupiter, Saturn, Uranus, and Neptune were about to line up in a rare planetary alignment. This only happens once every 175 years. The last time it happened, humans hadn't even invented airplanes. If they missed this opportunity, another generation would have to wait nearly 2 centuries. NASA realized this was history in the making. For the first time ever, a single spacecraft could visit all 4 giant planets in one mission. But there was one problem. How do you send a spacecraft billions of miles across the solar system? Space isn't a highway. A rocket can only carry so much fuel. Even the most powerful rocket of the 1970s couldn't accelerate a spacecraft enough to escape the sun and reach all 4 planets. So scientists came up with a brilliant solution. Instead of carrying more fuel, Voyager 2 would steal energy from the planets themselves. This technique is called gravity assist. The idea is surprisingly simple. Every planet is racing around the sun at incredible speed. As Voyager 2 flew close to a planet, the planet's gravity pulled it in and then flung it back out. Imagine throwing a ball inside a speeding train. When the ball bounces forward, it leaves with a little extra speed from the train itself. Voyager 2 did exactly the same thing. It borrowed a tiny fraction of each planet's orbital energy. First Jupiter, then Saturn, then Uranus, and finally Neptune. With every flyby, it accelerated. Eventually, it gained enough speed to escape the sun's gravitational grip and head toward interstellar space. This wasn't luck. It was one of the greatest engineering achievements in history. But finding the route wasn't the hardest part. Actually flying it was. When Voyager 2 approached each planet, it had to pass through an invisible target only about 150 kilometers, 93 miles, wide. Miss that window, and years of planning would be lost forever. Remember, this was the 1970s. There was no GPS, no real-time navigation, no onboard artificial intelligence. Everything depended on mathematics and precision. Voyager 2 carried a sun sensor to constantly determine where the sun was. It also carried a star tracker that locked onto a specific guide star to determine its orientation in space. Together, these instruments always knew which way the spacecraft was pointing. But whenever Voyager turned to photograph a planet or one of its moons, both references disappeared. So how did it stay stable? Using gyroscopes and spinning reaction wheels. These spinning wheels acted like invisible anchors, allowing the spacecraft to measure every tiny movement and keep itself perfectly oriented. After more than 2 years of flight, Voyager 2 finally reached Jupiter. NASA engineers held their breath. The result was astonishing. After traveling hundreds of millions of miles, Voyager arrived only about 1.4 seconds behind its planned schedule. Even today, that's considered an extraordinary navigational achievement. Then came Jupiter's gravity assist. The giant planet pulled Voyager inward and hurled it toward Saturn at even greater speed. The same thing happened again at Saturn, then Uranus, and finally Neptune. At every stop, Voyager sent back images humanity had never seen before. Volcanoes erupting on Io, the magnificent rings of Saturn, the strange sideways world of Uranus, the violent blue storms of Neptune. Each encounter completely changed our understanding of the outer solar system. Neptune was Voyager 2's final planetary destination. Beyond it, there were no more major planets. NASA made one final decision. Instead of ending the mission, they would let Voyager continue its journey into the darkness between the stars. In 1989, after passing Neptune, Voyager 2 never looked back. In just 12 years, it had completed the greatest planetary tour ever attempted. Today, Voyager 2 is still sending signals home. Because of the enormous distance, each signal takes nearly 22 hours to reach Earth. That's no longer just the edge of the solar system. That's the beginning of interstellar space. Many of the scientists who launched Voyager are no longer here. Yet every time NASA's Deep Space Network detects its faint radio signal, it's like hearing the voice of history. Most of Voyager's instruments have already shut down. Many systems have failed. But the little spacecraft built in 1977 keeps moving forward, silently carrying humanity's curiosity into the endless darkness. A machine outliving its creators, still exploring, still discovering, still reminding us that while human lives are temporary, our desire to explore the universe can last forever.